Ladies and gentlemen, please welcome to the stage Dremio co-founder and CPO, Tomer Shiran.
All right, thank you for joining me today here at Subsurface Live Summer 2021. I'm excited to be here with so many of you from so many different countries. And today I'll be talking about the future of data infrastructure and specifically three key trends that are shaping that future. The first trend I want to talk about is the shift towards open data architectures. We all remember from a decade ago that the way data architecture was done was a very closed and proprietary one. You basically had databases like Teradata, Oracle, and many others, where you had the storage, the data, and the compute all co-located in a single system. So if you wanted to use any of these systems, you would have to basically ingest the data into that database, and then you could use whatever that engine that came with that database was. Teradata came as, say, an appliance, and with Oracle, maybe you'd mount some external storage, but the data was tied to that one specific engine. What started happening when public cloud became prevalent was the rise of this new architecture in which storage and compute are separated. And what that means is that the database itself can leverage behind the scenes things like S3 or Azure storage to create kind of more flexibility in the architecture, but still the data is stored in that system in a proprietary format. So if you're using something like Snowflake or Redshift, you're ingesting the data into that database, and you can only use the capabilities that come with that one database to actually analyze or manipulate that data. And so there's a lot of limitations with this, and that includes, for example, the fact that there's significant vendor lock-in here. It becomes very difficult to get off of a database or a data warehouse in this kind of architecture. That also means that the prices become very high, and that typically goes kind of hand in hand with the vendor lock-in. What's happening now is the shift towards open data architectures, and this is something that we're very excited about. So in this architecture, the data itself is its own tier. It's stored in open source formats, open source file formats like Parquet files, JSON files, open source table formats like Apache Iceberg and Delta Lake. And on top of that, then you can have many different engines that can access and manipulate that data. So at Dremio, we've always been focused on the SQL use case, right? Things like BI workloads, being able to run ad hoc or dashboards on that data. But there are many other engines that people use on that data, things like Spark engines from companies like Databricks and AWS and Microsoft. And one of the nice things here is that you can choose the best of breed engine for a given workload. Not only that, but in the future, as new engines get created, you can choose those engines as well. It becomes very easy to spin up a new engine pointed at your data, at your open source Parquet files or your open source Iceberg tables, and start querying and modifying that data. So when you have this open architecture, one of the other benefits is that it leads to a very rich ecosystem. And actually, if you look at the speakers at this event, which are the logos that you see here on this slide, you'll see that they represent many of the world's largest tech companies, as well as various startups and open source innovators. And all of this innovation is basically being made available to you when you use an open architecture. Well, that might lead to the question, well, are open architectures inherently harder to manage or use, right? Because if you have different moving parts, well, does that make it harder? And I think the easiest way to answer that is to look at an analogy, something like this that we've seen before. And actually, if you look at what happened with application architectures and application development, we've seen a very similar transition. We've gone from monolithic applications to microservices, right? Where you have decoupled services that are independently scaling. And I myself used to be a developer, and I built a lot of web applications, initially using things like ASP.NET on top of SQL Server, and then using things like Django and PHP on top of MySQL. So very monolithic architectures. And today, everyone's creating microservices. And one of the things that's enabled that to happen is the tooling, and these technologies have really made it easier, right? Things like containers and Kubernetes, right? That have made it easier to build applications in this new architecture. Well, the same thing now is happening in this transition from cloud data warehouses, that closed architecture, proprietary systems, to cloud data lakes and lakehouses, right? This open architecture. And the two main things that have to happen with open architectures, in order for them to become easier over time, are number one, we have to make the infrastructure easier. And number two, we need to make data engineering and management easier. And if we can do those two things, it becomes very easy to have the benefits of the open architecture with, really that ease of use that we all want to have. So the second trend I want to talk about is how we make infrastructure easier. And I think a lot of that comes down to this transition from engines to services. And I know I've talked a lot about engines over the last 10 minutes, but really what we're starting to see is that more and more, rather than running software inside of in the cloud or inside of systems like Kubernetes, that ability to leverage SaaS services makes it a lot easier, right? You don't have to deal with software. You don't have to install anything or worry about upgrades or configuration or tuning. You can really work with these services the way you work with things like Gmail, right? You create an account, you log in, you start working with it, right? And these different services can all talk to that same open data tier, right? Those same open file formats and open table formats. Not only that, but in the future, what you'll see is the ability for these services to communicate with each other directly, because we're creating standards today that will enable that kind of very, very fast, very high performance integration between services. Specifically Aero Flight, which is part of the Aero project that we co-created years ago and is now downloaded 20 million times a month. With Aero Flight, different Aero-enabled services will be able to talk to each other much faster than before. Now, with respect to services, today I'm very excited to announce the availability of Dremio Cloud. Dremio Cloud is Dremio's SaaS offering, and it provides a SQL Lakehouse platform. And if you look in the chat right now, what you'll see is our virtual t-shirt cannon. If you click on that link, over the next few minutes here, you'll actually be able to get one of these Dremio Cloud t-shirts. So what is Dremio Cloud? Well, it basically combines the things that people love about Dremio today, right? The reason that hundreds of companies use Dremio to power their cloud data lakes today, including many of the world's largest companies, such as query acceleration, right? The ability to have sub-second response times and very fast performance on data lake storage without having to move the data into a data warehouse. The self-service semantic layer, which creates a unified and consistent view of the data for everyone in the company, all users, all tools, also allows you to apply kind of security and governance on that data. And then our best-in-class integration with a variety of BI tools, such as Power BI and Tableau, right, with native integration and single sign-on. So we can now combine that with the ease of use that comes from a true SaaS experience. Not having to deal with software, so there's nothing to install, there's no upgrades, there's no versions, there's no boxes to SSH into, configuration files to deal with. You don't have to collect log files to troubleshoot things. Just a much easier experience. And then also infinite scalability. So the ability to run as many queries as you want and not have to worry about whether I have one query a day or 1,000 queries a second. So this is very much like if you think about services like S3, which we all love because we can put as much data as we want into that system and not have to worry about, is there enough capacity? Is it going to get slow, right? Same thing with Azure storage. So we wanted to provide that kind of limitless experience for querying data. And then finally, workload isolation, because nobody likes it when the interns submit queries that are really, really complex and they impact the CEO's dashboard, right? And in most companies, we have a variety of workloads and we don't want any interference among those workloads. Of course, at Dremio, we've been dealing with many of the world's largest enterprises, many of the Global 2000, and so it goes without saying that world-class security is something that we built into the platform from day one. And then on top of that, one of the unique things we've done with Dremio Cloud is we've created a global control plane so that you can have a single pane of glass regardless of which clouds or which regions you're using. You can see all your data, you can define permissions and see all the privileges that you've granted, whether on data or on other objects, in a single list, in a single place. You can see who has access to what. You can see all the integrations that you have with your IDPs, your identity providers, different applications. All of that shows up in one place. And that's the value of having a global control plane. Now, how this is architected, if you look at this slide, it basically shows you the architecture of Dremio Cloud. So the engines which are executing the queries, we spin them up in your VPC so that they can run next to your data. Because a really important part of this architecture is that the data stays in your S3 buckets, in your control, and you're not having to take that data and give it to somebody else. And so we run the compute close to the data. And you can create different engines for different workloads. This is what provides workload isolation. So maybe a medium-sized engine for the executive dashboards and an extra large engine for data exploration. Each of these engines is auto-replicating. So whether you have 0 queries at night and there are 0 replicas, or it's Monday morning and everybody's hitting the same dashboard, and then you have 10 replicas of that same engine, that is all handled automatically. Now on the left, what you can see is the BI tools, right? And other data science applications. And we've created very nice integrations in partnership with these companies to Dremio's control plane. So if you take a tool like Tableau or Power BI, they come with native Dremio connectors with full single sign-on based on OAuth 2.0, and they can connect to that global control plane and send the SQL queries directly there. And then the control plane has an infinite amount of query planning capacity. So again, regardless of whether you're running one query or thousands of queries at the same time, you don't have to worry about that. We take care of that in our control plane. The control plane then uses query routing rules that you can create in the system to decide which engine is going to handle which query. So the queries are assigned to engines based on rules such as who the user is, what groups they belong to, what type of query they're running. And then, of course, a user can also explicitly select an engine if they have the permission to do that. So to make this more real, I want to invite Jason Hughes, who's a technical director at Dremio, to show you a demo of Dremio Cloud.
Thanks, Tomer. So what we'll go through here in the live demo of Dremio Cloud is we'll really frame it from 2 personas. The first being a data analyst, and we'll go through performing BI analysis on our data lake using Tableau. And the second being data scientist. And really what we'll simulate is actually a group of data scientists across an organization. So as Tomer mentioned, Dremio Cloud has a multi-engine architecture. So we can see the set of engines defined here within our environment. One of particular note is the data analyst engine. So we can see here with the data analyst engine, it's size medium. And we can see here details about the replicas within the engine. So basically, replicas are the unit of scale within an engine. So basically what this is saying is that the minimum number of replicas is 1 for this engine, and the maximum is 10. So Dremio Cloud automatically scale out based on workload from 1 replica to 10 replicas, depending on how much workload there is in the system. Further, we actually will cap it at 10. Certainly you could raise this higher, but basically this maximum number of replicas provides us a sense of really financial governance to allow us to cap at the number and say, okay, stop scaling at a certain point, because we would rather the queries queue at that point rather than incur that extra cost. So the other engine of note here is the data science engine. This is also a medium-sized engine, but we see here that this one actually has 0 as the minimum number of replicas. So we can see that currently there's no running replicas for the data science engine. As you can see here, also no nodes here in the detail. Basically what we said here is that, hey, if for data science queries, we would rather just shut the whole engine down rather than if there's no workload currently running. So let's actually go ahead and kick off the simulation of that group of data scientists throughout the organization. And basically what we'll do is use this script, which will just continuously bombard Dremio Cloud with 100 concurrent ad hoc queries, similar to something a data scientist would do, or a group of data scientists. So we'll just kick that off, and we can go ahead and look in the jobs page for Dremio, and we can see here's a set of queries that were kicked off, right? So this will end up being 100, and what we can see here is that it's actually going ahead and starting the engine. So if we pull up the engine view again of the data science engine, we can see that sure enough, it's starting the first replica, right? So we can see that here are the first 4 starting. So while that's happening in the background, let's go ahead and put our data analyst hat on. So keep in mind that as we jump to the data analyst scenario, there will just be continuously running 100 concurrent queries in the background. So with the BI analyst, what we want to do is perform trend analysis on taxi rides in New York City. So what we'll go ahead and do is go through the business zone of our semantic layer. We'll click the transportation folder, and here we have NYC taxi trips. So we're going to go ahead and select that data set, and we're brought to a preview of the data set. We can see that there's pickup, the drop-off, passenger count, trip distance, etc. Right? We can see that each record in this data set is actually an individual taxi ride. And in fact, it's actually over 1 billion taxi rides stored in our cloud data lake. So let's go ahead and jump into the trend analysis we want to perform. For this, we use Tableau. So we go ahead and select Tableau, and Dremio will actually generate and download a small pointer file. So we're not downloading any data. It would take way too long for that. And it'll actually open Tableau, and Tableau is actually configured for single sign-on to Dremio. So Tableau will actually automatically launch a browser tab where it says, hey, go log into Dremio. We're going to choose this organization. And this is actually configured to our enterprise identity provider, which for us is G Suite. I go ahead and select my account, and it redirects me, and it provides Tableau what it needs, and it says, hey, you're now safe to close this window. Great. I jump back over to Tableau. Just like that, I'm ready to do my analysis. I have the data set pulled up, and I didn't need to manage any credentials. I didn't need to input anything there. As well as on the IT side, you're secure in knowing that throughout all of the analysis, you maintain your authorization, your audit logging, your governance, etc. So we wanted to perform trend analysis. So let's look at the number of rides over time, where we can start. So we have a number of rides with each record in the table being a taxi ride. We want to look at the number of records in the table. So we go ahead and pull in the count of the records, and we can see, sure enough, there is actually just over 1 billion records. Again, this is stored in our cloud data lake. So let's look at number of rides over time. Let's pull in the time component. We see here that we pull in the pickup, and Tableau comes right back after it issued the query to Dremio and says, here's your result. We can add additional fields if we want, right? We can look at the tip amount, and maybe we actually don't want some. We actually want to look at the average tip amount over time, right? So something to keep in mind is I add these additional fields, as I do these additional clicks, drill down further in the time unit here, is that every single one of these actions is actually a live query back to Dremio. So if we pull up Dremio and go back and look at the jobs, and here we can see that the data science queries in the background have completed, right? Or at least there's a round of them. There are always continually more. If we refresh this page, here we can see the BI queries that we just issued, right? So here we can see the SQL that Tableau issued. There's the month. Here's the quarter. We can see that Dremio is continually responding in sub-second, right? Providing that interactivity, that almost sub-second response time for our data analyst queries. So we can also see that surrounding it, here are the data science queries, right? So what I was able to do is while there was 100 concurrent data science queries, I was still able to get that sub-second response time, and I didn't have to worry about it or plan for it at all. So if we pull up the data science engine, here we can see that now all 40 nodes, all 10 replicas are currently online, and they're serving the queries that have been issued, right? 100 concurrently since we started. Let's go ahead and actually kill the script. So this will actually terminate the connections. Dremio will actually end up canceling these queries once it hasn't heard back from the client after a set interval. And here we see that they start to get canceled, right? So we haven't heard back from the client, so we're going to go ahead and cancel these. Now, if we go back to the data science engine, this will actually eventually, after 1 minute of inactivity, so 1 minute from now, it will actually start to scale down all of these replicas, all of these nodes. So while we wait for that to happen, let's quickly recap what we saw. We saw that really Dremio Cloud allows you to provide you that isolation, right, between workloads. We had 2 very different workloads, a high concurrency data science, heavy lifting queries, as well as a low latency BI dashboard. And we're actually able to provide the experience that they need for both of them without having to worry, without having to plan for it. Dremio Cloud automatically not only isolated them, but also actually scaled out completely autonomously. So both on the query planning side, within the control plane happened automatically, as well as on the execution side, these engines really being able to, on the data science one, we saw that it went from 0 to 10, right? 10 replicas to 40 nodes. Now we can see that the workload hasn't run for 1 minute, so it starts to shut these down, right? So here we can see that this all happened automatically. It's stopping these nodes. So therefore, we'll go back to currently 4 for another minute or 2, and then it will scale down completely to 0 because that's what we have configured. We also saw that we were able to provide that performance of that sub-second response times, while all of these things were running, right? Going back to that heterogeneous workload, because that's really what happens in the real world, right? The last thing that we saw was around the single sign-on integration for Tableau and other BI tools as well. So with that, you're really able to not worry about the credentials that your users have to manage or type in, and as well as on the governance side, maintain the authorization, auto logging, governance throughout the analysis. So thanks. Back to you, Tomer.
All right, thank you, Jason. That was great. It was really exciting to see all those data science queries. 100 of concurrent queries, and still having that sub-second response time for the Tableau dashboard. That's something that I know many people will be excited about. So thank you for that demo. If you'd like to try this out, simply go to dremio.com/cloud and you'll be able to sign up there. So the next thing I want to talk about, and the last of the 3 trends that I wanted to cover today, was how do we make data engineering and data management easier? So about a year ago, I was talking to the head of data engineering at one of the big tech companies, one of our customers at Dremio. And the way he described the dream of every data engineer was that in an ideal world, the data engineer who's trying to maybe change some data or make a modification would be able to do that in isolation, right? They'd be able to do it kind of in a sandbox to make the changes and then verify that they've made the right changes. Once they're done with that, they would take that and publish that in one atomic operation, right? In one transaction back into the data lake. And so there was never a state where things are inconsistent. And the data engineer who's modifying the data is never working on the live environment, never in this risky situation where they might mess up and all of the analysts and all of the data scientists that are consuming the data are in a difficult situation. And then on top of that, one of the really important things that every data team wants is an undo button, right? So that you can't mess up. You can always go back in time. You can always revert the last few changes if you have to. And that means, the chances are you're never going to be stuck, working all night to fix something or working the weekend because you've left something in a bad state. This is now becoming possible. This dream scenario, because of a number of new technologies, is actually about to become reality. And one of those technologies is the rise of open source table formats, things like Apache Iceberg or Delta Lake. And so Iceberg, for example, is a project that we're excited about that was created by Netflix and has many contributors from many of the largest tech companies now who use Iceberg for their data lakes and lakehouses. And it provides a number of key benefits. But fundamentally, it's providing a transactional table within the lake. So for example, the ability to perform mutations at the record level with DML operations. You can insert a record or update a set of records or delete records that match some condition. You can create partitioning schemes when you're creating a table or modify the partitioning schemes, and users don't have to worry about that or know about it. The queries actually don't specify what the partitioning key is. And then if you ever want to change that partitioning key or one of the keys, or if you want to change the schema of a table, it becomes very easy to do that. It's basically one simple alter table statement that you have to run. And it finishes instantaneously. It doesn't take any time. And then also the ability to query a specific snapshot. So as I mentioned, these formats are transactional. They kind of move forward in time. So you have the ability to query a previous snapshot at any time. Iceberg and Delta Lake operate at the single table level. And what we've done at Dremio is we've created another open source project called Project Nessie, which provides a new and more modern metastore for the Lakehouse. And we've actually borrowed some of the concepts that will probably be familiar to most of you from the world of Git. And these 2 concepts that we've borrowed are data branching and data version control. So for data branching, which basically provides transactions as well, you can create a branch, as you can see in this example, where we're creating an ETL branch, which we then use. And we do these things from SQL. We can then insert into that table, update that table, and then merge that branch back into the main branch, the main view of the data lake. So all the analysts and the data scientists can actually see those changes as one atomic operation. In addition, in terms of data version control, you have tags and commits. And those are kind of consistent, transactional at the entire data lake level. So you might create a tag for the end of month financial data for August, as you can see here. and then go back and say, you know what, I want to use the July end of month data to see how things compare. And so you can select star from a number of tables as they were when the tag July end of month was created. And you can even do that at an individual table level within a SQL statement using the at character. So it turns out that this approach is actually much more aligned with kind of how data engineers work, with the real world. And if you compare this to database transactions, which were really designed for OLTP applications, right? They were designed for a world in which you have one session, one user, everything's being done from SQL, right? This would be great if what we were talking about was, moving money from one account to another account. Right? If you're an app developer building an app, these types of transactions are exactly what you want. Right? You run a begin transaction command, you do a number of inserts and updates and maybe some deletes, and then you call the commit statement, and that's a transaction. But that's not how data engineers work, and that's not how the real world operates, right? How companies work. In the real world, you typically have multiple sessions, multiple users, potentially multiple different engines and services that are operating on the same data. And that's much more aligned to how data engineering teams work, right? And so in this example here, what you can see is that we've created a branch called ETL, and we then ingest data from Kafka. Maybe we run some bulk export from our RDBMS. We then run various Spark and Dremio transformations, maybe some additional SQL statements or Spark jobs. And then when we're done with all of that, and maybe that took an entire afternoon or entire week to actually get the data ready to the state that we want it to be in, we can then go back to the main branch and merge the ETL branch into it. So to make this more real, I want to hand this over to Tom Fry, who's the director of product at Dremio, and he's going to show you a demo of what this actually looks like.
Great. Thank you very much, Tomer. So to demonstrate the power of Nessie and its ability to work on multiple different versions of the data lake at the same time, today we're going to walk through a quick scenario with two independent personas. The first is a sales manager here, and this sales manager is looking at the data lake to identify the top customers in the current month across multiple different tables within the data lake. We can see here that the current month is 6 for June, and that they have a certain set of top customers in the current month. And they're always running this against live production data. The second persona is a data engineer. And this data engineer needs to go through a typical ETL process to update the data lake. But they want to do so in a protected, isolated version of the data lake so that they can make sure that everything's okay before publishing data to users. The first thing we're going to do is look at what versions exist within Nessie. And we can see here that we have one main version, which is for production data. And it's actually very easy using Git-like semantics, which software developers always do, to create essentially a new branch for ETL data. And now we can see that we have two different versions of the data lake, our production version and an ETL version. But they're both the same with the same commit timestamps, the same commit hashes, because we haven't changed anything. The next thing that we can do is we can look at what context we're working in our current SQL session. And we're currently operating on the production version of the data lake. However, it's very easy and trivial in Nessie to jump between different versions of the data lake. And can we see now that we switched our session over to the ETL version so that all of our changes are made within an isolated version with Nessie. The next thing that we can do is use Apache Iceberg to insert new data in a transactionally consistent manner into multiple different tables. And now when we look at what versions exist in the data lake, we can see that our ETL version of the data lake has moved forward and we have new commit hashes because we've modified it. However, the production version of the data lake is still the same. And in fact, even though we've inserted July data, our sales manager who's working against the data lake is still seeing June data with the month 6. Now our data engineer wants to verify those changes. And so this is a quick query to make sure that all orders have an associated customer. And we can actually identify here that there's some orders that are missing a customer reference. We actually have a foreign key relationship problem here. This is a failure scenario. This means our data lake is currently in an inconsistent state. This is a type of scenario that happens quite often, usually at 3 in the morning. It's when data teams have to run around and figure out what's wrong and how do I fix it. However, in this scenario, even though our updates are broken, we can see that our sales manager is not exposed to them. Our sales manager is still working on published and verified June data. The next thing our data engineer can do is fix the ETL branch. There's actually a couple ways they could do this. The first is they could drop the branch and start the process over. Just like in Git with software developers, creating and dropping branches is essentially a free operation, even if here it's against a petabyte-sized data lake. Another option we can do is fix the version that we're working on. And so what we'll do here is we'll do that. We will update our customer table and fix the data lake, and we can do so and rerun our verification checks and find that, yes, all orders have an associated customer. The last thing that our data engineer wants to do is publish this data, and they want to do so in a transactionally consistent manner, even though we have multiple tables in the data lake. So the first thing that we're going to do is switch back over to production context, and we now can run a merge statement, which updates the entire data lake with the changes from our ETL branch. And what we can also look at is now we can see our versions of the data lake are the same because we've taken our ETL changes and published them to the production version of the data lake. One of the powerful things here is even though we have multiple different tables in the data lake, all of these tables were updated in a transactionally consistent manner, just like you would see in a regular database. Now, if our sales manager runs the exact same operation against the data lake, he now sees July data and the new set of top customers for July because we've published the July data. But he's seen this in a consistent manner with verified data. The last thing that we're going to do is reproduce past results. And so what we can do with Nessie is create tags for historical versions. So first we'll create a July tag for the latest data. And we can now see that we have two different historical reference points. One is for the June data and one is for the July data. And we can also see that we're currently working in the production version of the data lake, which has July data in it. But it's also very easy to switch between different versions. Here we're going to quickly switch over to the June reference point. Now we can see that we're currently operating on June data. It's read-only because historical data is immutable and cannot be updated. But actually with Nessie, we could create a fork of it and do experimentation purposes on historical data in another private version. But what we can see here is since we switched over to the June reference point, across all tables, we're now looking at June data. It's also very easy to switch back and forth. We can switch over to the July reference point, and even though we're referencing multiple tables, we can now see that we're seeing July data. So it's very easy to switch between entire versions of the entire data lake environment. This enables people to reproduce past results, for example, with machine learning models, and show what did they reproduce to answer what-if questions 3 or 4 months ago. And it's possible to reproduce the exact same results that you had in the past. So we're very excited about this. We know a lot of our customers that we talk to are very excited about this, and it's really going to help data engineering teams with a lot of the operational challenges that they face with today. So thank you very much, and back to you, Tomer.
All right, thank you, Tom. That was really exciting. So hopefully all of you are as excited as I am about these types of capabilities that are coming to our cloud data lakehouses. So if you're interested in learning more about what you just saw and some of the technologies that are involved, such as Nessie, Iceberg, and Delta Lake, we have a number of talks lined up for the next couple of days. So please go ahead and attend these. And actually in half an hour, we have Ryan Murray talking about distributed transactions on the data lake with Project Nessie. So he'll share a lot more technical information about what we just saw. So thank you again, everybody, for joining me today. We have thousands of people joining from all over the world. I'm excited to have you here at Subsurface, and I look forward to chatting with you some more over the next few days.
Ladies and gentlemen, please welcome back to the stage Dremio co-founder and CPO, Tomer Shiran.
All right, thank you. And thank you, everybody, for joining from wherever you are. It's great to have you all at Subsurface Summer 2021. And today I'm excited to have Kevin Miller, the General Manager of S3 at Amazon, join us. Kevin, thank you.
Yeah, Tomer, thanks for having me. And if I'm not mistaken, I believe we are both alum of Carnegie Mellon. So good choice there.
Oh, that's right. All right. That's the even more important title here. So yeah, it's great to have you with us today. And so
Thank
Kevin,
you.
you're responsible for S3, and I think everybody here that's joining today is very familiar with S3. But What they might not be as familiar with is what is it like to run a service like S3 at that kind of scale? And maybe you could give us a sense also of some of the scale and kind of the operation that you're dealing with.
Yeah, well, I mean, it's a privilege, and it's really a lot of fun actually to run S3. You know, it's a service that continues to scale and sort of mind boggles even those of us who have been around for a while and managed it through a lot of growth. You know, we have more than 100 trillion objects in S3 today with just massive request rates, and so you know we take that as a very significant responsibility to maintain, you know, first and foremost, the security of the service, but the availability and the durability focus. And really just, you know, we come in every day really saying, what can we do to raise the bar across the board in security and availability and durability? And then ultimately, you know, both cost and performance and the set of features that we have available to customers. You know, when we have customers growing from what used to be perhaps terabytes of data to a few petabytes of data to tens and hundreds and even more petabytes of data that they have in their data lakes, it becomes, there's just a lot obviously that goes into that. And so helping customers day in and day out manage and scale and operate and not have to worry about, of course, adding capacity or the performance, the day-to-day performance, that's all our job to do. And so you really, what's really exciting is when you see customers that are able to focus on their business and solving the problems that are unique to their business and in front of them. And so, for example, you know, I was a customer like NASDAQ who, of course, in the middle, over the last 18 months, the stock market has had some pretty interesting days that have scaled up and scaled down. And, you know, they actually use S3 and Redshift and some other services to analyze their data. And, you know, we're able to scale from something like 30 billion requests to 70 billion requests a day, you know, with that. And so that's the kind of ability to scale that I think is really exciting. And I think certainly, you know, for our mutual customers, giving them that ability to scale and to analyze and process just massive data sets is something that, you know, we're looking to. It's an exciting part of the job, and it's rewarding to see customers really able to transform their businesses with that.
100 trillion objects, that's a lot. That's kind of mind-boggling when you think about it. And you know, I was checking out the site this morning, and it you know, highlights 11 nines of durability, and I have no idea what 11 nines of durability. What 11 nines mean? I've never heard of that before. And you know, so tens of billions of requests for a single customer. That's crazy. So quite the operation.
Yeah.
How many regions are you operating in around the world?
Well, we have, I think the current count is around 26 regions around the world. And so, I mean, S3, of course, operates in every region that AWS has infrastructure in, which is, of course, all major countries around the world, and is growing. You know, we're continuing to add sites. We launched in Bahrain and Cape Town recently, and there's more coming. So, yeah, we, you know, certainly what we're hearing from customers is an interest in having data close to them. Sometimes there's data sovereignty type concerns that are arising where customers absolutely have to have data in that country. And so, of course, you know, one of the things we provide, 11 nines of durability speaks to the resiliency we bake into S3. A lot of that is through our AZ architecture, where we have in each of those regions, it's 3 independent data center buildings. So when we talk about an availability zone, which is really the underpinning for how we provide that 11 nines of durability, it's done through independent buildings within each of those regions, and all of our regions are built that way. So it's a lot of work actually up front to build out a new region. We don't just go in sort of with a small footprint that is unable to provide the resiliency. Every region provides the resiliency.
It's interesting, and actually, you know, the widespread availability of S3. We just announced our cloud service this morning on AWS, and you know, one of the key parts of that architecture is the ability to run the compute where the data is, right, and let the company keep the data in S3 in their own account under their own control. So that kind of flexibility to run anywhere is a big part of the benefit. So what are, you know, with this kind of scale, you know, the numbers are obviously hard to comprehend. What are some additional kind of stories or examples of customers that you work with that get you excited?
Yeah. Well, I think that probably the largest use case, which of course speaks to exactly what where Dremio I think fits into the picture, is all around large scale data lakes and customers that are increasingly looking to abstract away the idea of where is my data, and having to have data silos where data is tied to a particular schema and is baked in, is stored in a particular way, is arranged in a particular way. They're looking to get rid of that and instead have the primary data sources, but be able to issue queries and analytics and machine learning training across the whole of their data and whatever data needs to be joined in for a particular operation. And what that's leading to is what we're seeing is some business transformation, which to me is actually the most exciting, really interesting part of this. Is you see businesses that are able to just change the way they operate day to day, and increasingly data lakes are growing from being something that might generate a report that a human looks at to something that's actually feeding directly into the production systems that run a business, which is really exciting. So, as an example of that, I would highlight Georgia Pacific. They're a customer of ours, and they actually use machine learning in their data lake to determine how fast their production lines run, so that they can minimize the downtime from machines that are offline due to being jammed or running out of upstream supply. So they're really, and that translates for them. They can immediately translate into profit based on the downtime that they avoid from those machines. Another example I would highlight would be one of India's, actually I think it's India's largest online supermarkets, Big Basket, who really helps customers shop quickly online. And of course, in the middle of the last 18 months, they saw tremendous growth from people that wanted to buy online and just have groceries delivered to them. And so they use their data lake and analytics on top of it to generate and drive recommendations for their customers. So they can probably predict if you always buy a certain set of things or you prefer certain brands, they can probably predict and give you some pretty good insight about what you might want to be, what you might be shopping for when you visit their site. So those are just a few examples. But like I said, I think all of those really speak to a transformation that I'm seeing in general of those data lakes being used for ad hoc and undirected or kind of reporting that a human is sort of human in the loop, and moving towards something where it's just part of a day-to-day process for a business to be using the whole of their data lake to make those decisions.
That's definitely some interesting examples there. I know we have many joint customers in many different industries, and we've both seen a lot of migrations from on-premise data lakes as well as cloud data warehouses to this kind of cloud data lake architecture, and some call that the Lakehouse architecture now. What do you think is driving these migrations from these different architectures onto kind of the cloud data lake?
Well, I mean, I think one is around managing cost and sort of a constant desire for customers to look at how can I do what I'm doing today, but do it more cost effectively, right? I mean, that's an obvious thing that the customers want to do. But I think that, that's one piece. I think the scalability benefits of running in S3 where I don't have to think about provisioning storage. I don't have to purchase storage in large one-time, capital investments, right? Where I'm spending potentially millions of dollars. And what that leads to when you don't have to work, when you can scale up and scale down, more importantly, and both of them are important, but being able to scale down when you don't need something gives you that ability, I think, to really innovate and to experiment around the data and saying, what if we tried? What if we have an idea and we try it out and we pull some data together, we look at the results, and if it really works out, then we can scale it up and continue doing it. Or if it doesn't, that's no big deal. We turn it off. We stop paying for what we're not using. If we have a large data set that we no longer need, we can delete it or we can archive it. We can put it in with S3. We have different access tiers and storage classes where customers can pay as little as $1 per terabyte a month if they put it into our deep archive storage class. And so, oftentimes in those kind of cases, we would recommend, if you don't have a current use for the data, you can stick it in archive and maybe maybe in a few years you find something new, or you find that data actually does have value to go back and look at. So I think it's really around the innovation and the scalability. And then I would also just say that one of the things we're spending a lot of time with working on feature-wise is just helping customers manage their data at scale, secure it, provide secure access to it, and do that in a way that, again, that can be mapped pretty closely to those workloads. So, if I have a new workload, for example, if I'm spinning up, I have a new set of Dremio users at my site that are looking to experiment with the data, I could spin up dedicated access for them, or a specific set of access permissions for them, and let them work through the data. And then taking that into production, I can review that and add different access permissions to really lock it to the particular the needs. And so I would highlight I think one of our joint customers that I would highlight here is FactSet. I think they are using S3 and Dremio to have that single pane of glass around analytics insights and sort of joining data across their different data silos, including some that are sort of established data sources that are different locations, as well as their data lake in S3, and just kind of joining across all that data. I think that is a good example of that kind of ability to innovate and sort of experiment and not be and do so actually at the same time that data might be in movement, right? You might have some data here, some data in S3, some data somewhere else, and being able to do that while that data is in different spots, I think is very valuable.
Yeah. Yeah, and that infinite scalability you talked about is something we talk about internally as well. When we're talking about Dremio Cloud and describing it, and anytime somebody challenges me and says there's no such thing as infinite, I'll often point to S3 as an example. Yes, it's not truly infinite, but it's for all practical purposes. You just don't have to worry about it. Yeah.
It's not magic, of course, but that is what we say and we do. And part of that is, what you were saying earlier of like the fun of running S3. I mean, it's, there's a whole team and they work on nothing but making sure that we are continuously scaled for our customers' needs. And so that's a pretty important and very interesting. There's a lot of innovation actually under the hood of how that really happens, and building systems to manage that. So it's not magic. There's a whole team working on it, but that is certainly what the benefit of S3. So.
Yep, that's very cool. So I want to talk a little bit about we've been partnering together, Dremio and AWS, and actually working across many teams at Amazon. I think the SaaS Factory team today blogged about how we work together on our service, and but both at an engineering level, many of the product teams at AWS and the go-to-market teams as well. I'm curious, kind of from your perspective, what excites you most about this partnership?
Yeah, well, it's a great partnership, and I really appreciate all the work that you've done, Tomer, and the whole teams have done together. I think that, what excites me a lot is kind of that example I was sharing with FactSet, but in general, that ability to generate analytics and execute queries and process data across multiple data sources, and do so in a way where the end users don't always need to know exactly where that data is. They can execute a query against a table or against constructs that they understand and that they can relate to, and connect what they're doing to the data that they have, and not need to necessarily know all the underlying details about where that data is stored, how it even gets there. There's a whole there can be whole pipelines of sort of ingesting and pre-processing or staging the data that they don't have to be aware of. They can just focus on the thing that really matters to them, which is all around generating insights and like I said, finding ways to really get value out of that data to drive the end business goals. That in the end is what I think both of us really want to see in our customers, is that their end business goals are being met and achieved. And so the less time that people spend having to think about where is this data or how do I get access to it, and then just being able to do the analysis that they want to do, I think that's tremendously valuable. And I think that I think that leads to an agility that many customers need today, in terms of being able just to experiment with new ideas and try their hypotheses, and then when it works, finding ways to then productionize that and kind of make that a mainline activity for them. So, I think another example, we mentioned FactSet, but I think another example that I'm aware of is KKR. And my understanding is the way that they are able to really streamline. For them, it's all about doing deals, and how do they get all the data they have, pulled together into a view that gives them that insight to say, should we move forward, or where do we have risk, and how do we mitigate that risk? And so being able to pull our data out of their data lake as well as other data sources and pulling that together into a view that allows their business leaders to make decisions around it. I think it's a great example of that kind of agility that mutually we can provide.
Yeah, and S3 really is the underpinning for so many of so many cloud data lakes and hundreds of our customers. And of course, as the SQL engine for these cloud data lakes, they of course depend on the capabilities of S3. That's a key part of the experience that they have. So there's a lot of innovation. I think people might think of storage as, okay, it's just I put data in there and I pull it out, but there's a lot more to it. And it's bits and bytes. But I know you guys have been doing a lot of really interesting things beyond that. So I was wondering if you can share some of the things that you're excited about in terms of the technical things that you've built recently that could help some of the folks listening.
Yeah, I think there's a few things that I would highlight. And I think the cool thing is, of course, that we can innovate and deliver this kind of capability. And then Dremio customers who are using S3, they get this, out of the box. This is something that they then have access to. And it's not something you have to build on top of it. We can, really innovate mutually with this. But I think one thing is we launched last year the Storage Lens, and I'm really excited about that. It's really the first capability for cloud storage that gives organization-wide visibility into how storage is being used. And so our customers are using this. Many of our customers have large organizations where they have tens or even hundreds of AWS accounts, and those accounts could be for different projects or for a development versus test versus production environment. And so they just end up with a lot of accounts, and they have data in those accounts. And really, what they were asking us was, how do I get my arms around what I'm doing? Where am I storing data? Is all my data encrypted at rest? Because that might be a requirement for my company or my industry. And am I really cost optimized, or where should I look to further cost optimize? So that's all capability that we built in the Storage Lens. Customers can view that out of the box, and then also there's some additional options that you can pay a little bit more, and get sort of prefix level, really drill in to if they've identified this bucket or this account has a large amount of usage, and I want to figure out how to cost optimize it. They can focus on specific prefixes and really drill in. And then a lot of that cost optimization comes in the form of there's many ways to cost optimize, but oftentimes it's around using our different storage classes, including using our S3 Intelligent Tiering storage class, which continues to be one of our fastest growing storage classes. We launched that a couple years ago. And the whole idea of intelligent tiering is that, which I think is particularly suited for data lakes, because customers came to us saying, I do want to cost optimize. And so I want to take data that might be in the S3 standard storage class, which is kind of our baseline, and I want to put it into S3 infrequent access, or even into one of the archives storage classes around S3 Glacier to really reduce the storage cost. But the challenge is I don't really know which data is hot and which is cold. And as we were just talking about, it might be the case that certain data is very cold, but then a new deal comes in, and now we need to analyze data from a different industry and kind of that data will heat up very quickly as we go and do that analysis. And so what customers asked for was, can you just kind of take care of that for me? And that was what begat the S3 Intelligent Tiering storage class, where there isn't a cost to retrieve data. If it's accessed, it's pulled into our frequent access tier. And then if it's not accessed for a period of time, it will then go back into an infrequent access tier automatically, or if customers choose, it can also go into an archive tier. We launched that ability last year as well. And so for data that's not frequently accessed, that can be automatic cost savings that intelligent tiering just does based on which data is actually being accessed. So that's been really, I think, really beneficial for these kinds of use cases. And for some customers, it just leads to automatic savings. Very low. They don't have to think much about it. They sort of opt in and can save 10 or 20% right away.
It's interesting. You mentioned the storage lens, and we actually internally we use that, and we actually leverage the fact that you can actually have that dump to Parquet files on S3, which we then query with Dremio for our internal data lake. Yeah,
exactly. Yeah, no, absolutely. I mean, and I think it speaks. I think it speaks to just that kind of that open architecture, open data architecture around really making it easy for tools like Dremio to look at data and to be able to not have to constantly rewrite data basically for different access patterns or analysis methods. So
yeah, the other interesting observation here is just how much you do to kind of help customers save money, right? A lot of the innovation is actually about that, which
absolutely
we talk about internally as well. It's about customer success, right? And actually, this morning I was looking at your site, and I think one of the big blog posts is 5 ways to reduce your storage costs. So that was pretty cool.
Right.
Yeah.
No, we want our customers to be successful, and cost optimization is definitely a big part of that. And so, both Storage Lens and Intelligent Tiering really speak to it.
Yeah, and we deal with that the compute layer, right? All about how do we spin down the capacity to 0 if at night nobody's using it, right? Or things like that. Yeah. Cool. Yeah. So let's shift gears here for a second and talk about the future. So I know you don't often share details about roadmap, but I was wondering, what are some of the things that you're excited about in terms of the roadmap that you have for S3, to the extent that you can share with us?
Yeah, obviously, there's going to be a lot of details around where we're exactly going that I won't be able to share. But I think that what I will say in general, what we're doing is, I believe that we're still in the very early days of what we will see in the fullness of time for customers in terms of their data lake and the scale of data lakes that they have and what they're doing, how much data they're collecting and processing and making part of their business. I think we're just in the early days. If I look at kind of the scale and impact of data lakes for some of our customers who I would say are doing the most, and compared to those who are ramping up and figuring out how they do more, I think there's a lot of opportunity there. And so I think when customers start to look at what data do I have that I might be throwing away today, whether that's kind of website clickstream analytics or data, mobile engagement data that's coming off of mobile apps. I just or data from IoT sensors. You just go down the list. I mean, there's a number of data sources that I think we're just nowhere near tapping the full potential for. And then that potential to, once the data is collected and available, and using obviously tools like Dremio, being able to look at that data and make decisions off of it. So, what we see as important in our roadmap is helping customers cost optimize, as we said, manage their data at scale. We launched S3 Batch Operations a few years ago to really help customers say, I need to update, I need to make some changes across billions or tens of billions of objects, and how do I do that efficiently? And that's really what begat our batch operations capability. And then earlier this year, we launched the S3 Object Lambda ability, which is now you can use the S3 API and use our SDK, just basically point at an access point, an S3 access point in the SDK, and then you make a GET request. The application will make a GET request. Behind the scenes, before the data is returned, we invoke a Lambda function that the customer specifies. And then that Lambda function, really, it's a full Lambda function. It can do whatever you want with the underlying data. It can strip a column out. It can bring in another data source and add a column in. It can create an aggregation. It can perform row-level access control and filter out certain rows that maybe that person's not allowed to see. And so that's I think a really interesting capability. We've gotten some, we've gotten some really early, interesting early use cases for that, including Ryanair building an app for their COVID verification process. And so, we're all around, we're pretty excited about where that's going. There's definitely a lot of innovation, to be had in that space in terms of executing those kinds of inline functions. So that's an exciting one. And, I think just overall, really looking at the scale of data lakes, the idea of an open data architecture, which I know is important, I think you view that as a pretty important capability overall, or important mental model. I think that's something that we just want to be there helping customers with the right features and capabilities and cost and performance to make that a reality. So.
Yeah, makes a lot of sense. Open data architecture and reducing data copies is obviously a big priority. Just makes it hard for companies to make use of their data when there's tons of copies flowing around and nobody knows what's there. And so clearly you've done a lot to whether it's the Lambdas or the storage lens to help companies kind of address that. So I know we're getting close to the end of our time together here, and I certainly learned a lot of new things that I actually didn't know before about the scale, about some of the things you're working on. Clearly, data lakes are a huge priority for AWS and
yeah, absolutely,
and for S3. So if there's one big takeaway or piece of advice for the audience, what would that be?
Yeah, I think that the thing to think about and important in this industry is that change is inevitable and change is continuous. And so really what I would encourage customers to do is to set themselves up for that kind of change and expect that there's going to be iteration and improvement, and that's kind of the important thing to think about when building an infrastructure and architecture is, I think that, historic thinking around, I'm going to build the architecture and that's going to be my architecture for 10 years is just not going to be the reality. And so finding ways to store their data, which we can help with, and then process that data in ways that gives them that kind of agility, including agility around where is the data actually being stored right now. Maybe it's in S3, maybe it's sitting in a different location because it hasn't yet migrated, or maybe there's a new data source that's coming online that we want to tap into quickly. I think just being able to thinking about it in terms of this will change, and how do I make sure that the applications and the workloads that I'm running on top of it are adaptable to that kind of change and iteration, and not just sort of locked into, this is my application that uses this query language that accesses this data, which is organized in this way, which I think is just increasingly not the way that our systems really work. So that's my biggest takeaway.
Yeah, that flexibility with today's data volumes and agility that companies need, that flexibility seems to be is a must, for the future. All right. Well, thank you, Kevin, so much. Everybody, please join me for a virtual round of applause. And it's been great having you here today. And we actually at 10:10 we have a session with Roy Hassan, who's a product manager at AWS, and we'll be talking about how to build scalable cloud data lakes on AWS. And so that'd be a great follow-up for this session. Thank you, Kevin.
Yeah, Timur, thanks for having me. It's great to chat.
All right.